At this point, you should have read through the power rule and a couple of the other rules listed in the notes. And so now we're going to start using these rules to find the derivative of a function. So as opposed to before using our limit definition, now armed with these rules like the power rule and a few of the other ones, we're able to find derivatives a little bit quicker. So consider first the powered function f of x equals x to the 8th. Well, remember our power rule says that we're going to multiply by the exponent, then decrease the exponent by 1, and that will give us our derivatives. So it's actually really cool that the derivative has such a nice little pattern like that, so that when we have a power of x like x to the 8th, it's really easy to do the derivative. It's just, in this case, 8x to the 7th. As a second example, consider the function 1 over x to the 4, x to the 4th. That also has a power, but that power is in the denominator. Our power function only works if it's x to a power, not when x is in the bottom. So we have to take that x to the 4th, and remember that that would really be x to the negative 4th power. X to the negative 4th power. And now we can apply our power rule. Power rule again says, oh, I don't know what just happened. Bear with me for 1 second there. A whole bunch of stuff just popped up on my screen. So, got way ahead of myself there. So back to the problem here, f prime of x. We multiply by the exponent to be negative 4, and then we drop it by 1. Now we don't prefer our answers to finish off with negative exponents. It's often convenient in the middle of a problem, but towards the end, at the end, we want to get rid of the negative exponents. So we remember that negative exponents belong in the bottom. So we take that x to the negative 5th and we shift it down, and our answer becomes negative 4 over x to the 5th. Negative 4 over x to the 5th. Our next example here involves a radical. Specifically, it involves the radical 4th root of x. Now, for us to be able to do the derivative, we need to have this expressed as a power. That's our power rule. So, second thing is this 4th root of x, because it's an even root, not defined for negative numbers. Okay, so neither will the derivative be defined for negative numbers. So what we do is we remember that roots grow in the ground. That 4th root, when we write it as a fractional exponent, is going to be in the denominator. And inside we have x, which is also x to the 1st. So the 1 goes into the numerator. And so 4th root of x can be written as x to the 1/4. X to the 1/4. And now we're ready to do our power rule. So we again go in, multiply by the exponent, and then decrease it by 1. And when we decrease it by 1, we'll get negative 3/4. Again, now we have a negative exponent, so that should move to the bottom, become 1 over 4x to the 3/4. If you want to rewrite that 3/4x to the 3/4 as 4th root of x to the 3rd, you certainly can, or we can leave it with the fractional exponent. Let's consider one last example here. This time we have a number there, negative 5 in the numerator over x squared. So once again, we rewrite that as negative 5, x to the negative 2nd. And now negative 5 is a constant, so that's going to factor out front of the derivative using our constant multiple rule. And then we do the derivative of x to the negative 2nd. So we multiply by the exponent, which would be negative 2, drop it by 1. And then we just clean things up and simplify. Negative 5 and negative 2 would be 10. X to the negative 3rd needs to go to the bottom. And so it does, and we get 10 x to the 3rd. 10 over x to the 3rd, sorry. Okay, so we're going to continue looking at some more of our rules with derivatives in the upcoming examples as we do more and more complicated problems.